Hey Krishna, can you hear me?
Hi, sir.
How are you?
Good, sir.
Happy New Year. So, did you receive two of the lessons, as I said in the email?
Yes, sir. I received two.
Okay. Yeah. Okay. I need to. There's some confusion on my end that was causing the lessons to go through. But hey, Jishnu.
Hey, how are you?
Good. Happy New Year.
Happy New Year.
How was the holidays? Did you
Yeah,
have some days off?
I actually took my holidays during December, like during Christmas, and
Nice. Nice. Did you do anything fun?
not really. I was just relaxing. I was always there at my home, and
Mhm. Yeah. I guess a relaxing holiday is sometimes much better than an eventful one.
yeah, exactly.
Yeah,
If it's the other way around, you need to plan for a trip.
exactly.
Every You won't actually take good peaceful. You won't actually get some peaceful time.
That's true. Actually, I mean, there are some people who hate to just be relaxed and sit down and have a like a non-eventful vacation. I've seen friends who like even when we go out to for a trip or something like that, I'm the kind of person who'd be like, okay, no rush, let's just relax. If you cannot get to some place, that's okay. You just see what we see. Uh, but then there are others who would be like, you have to get up early, you have to go to cover as many places as possible, come late, sleep for a little bit of time, and then do the same thing again over and over again. So yeah. I find it hard to understand that logic, but I know people like that exist.
Yeah, like even for me, there are friends who does things like that.
Mm-hmm. Yeah, I guess it's kind of like how you treat the vacation. Do you treat it as a relaxation or regeneration time, or do you treat that as an utility? And if it's an utility, then you want to get the maximum out of it, right? So,
Yeah, exactly.
uh, uh, I don't like completely not see the logic there. I mean, there is some logic there. Like if you spend a lot of money and time to get there, maybe you should explore, but it comes at a balance. So, um, anyway, topic aside. So, I didn't know that you were not on the mailing list. I should add you to that list. And regarding the challenge, did you get a chance to go through it?
Yeah, I've actually gone through that, and it's quite interesting.
Okay. I can add you in. In fact, like I wanted to add you and Krishna into that um, even before this, I started the challenge to like for you guys to go through it and give me like honest feedback. Um, so if you're interested in that, I'll just go ahead and add you in. I already added Krishna to this. The thing about the accountability fee, you don't have to worry about it because I know you guys have been coming to the office calls regularly, so I don't have any problem with accountability with you guys. So if you're interested, I'll just go add your email in, and then you can get started on that. Um,
Yeah, actually, I'm very much interested. Like I
okay,
was searching for something different to get started with the new year.
okay,
So I think this
okay, cool. So I'll
this is
I'll get started. I already added
that will
Krishna
do.
into that. Sorry, you were breaking up. Can you repeat that? What was
Yeah,
the
I
last?
was saying that I'm actually interested to join you guys.
Okay, sounds good. So Krishna is already in. I'll add you in as well. And so what I want from you guys is real honest feedback. So The first couple of lessons are going to be a little easier on the easier end, so that it's kind of well, the whole challenge is set up so that it's easy for anyone to come in without any robotic knowledge to kind of come in and do the stuff. But the first few lessons is going to be a lot more easier. So that's that. And then probably in the very end, it'll get a little complicated, but not a whole lot complicated. But what I wanted from you guys is just go through it, give me like real raw honest feedback, like, okay, this is good, this is bad, this is confusing, this is like um, maybe maybe you should explain this more, or maybe you should not explain this on this, or this lesson is not serving, something like that. So every day after you get that lesson, just drop me a message on Slack, because if you try to accumulate and send me feedback, that's not going to happen. So just send me a DM on Slack saying that, okay, I went through this, this is good, this is bad, just a feedback. Okay,
Yeah, sure.
cool.
Totally agreeing with that.
Yeah. I'm also working on creating something a little bit more mathy, like having some math to it. Um, so I wanted to create something simpler before going into, I mean, it's hard to um, it's really tempting to start something which is more mathy, but I kind of like stop the temptation to kind of come up with something which is simpler, and then I'll go to the complex one. So that's something that I'm kind of working on. So I'll let you guys know once that gets ready. Okay, let me admit Shruti here. Hey, Shruti. How are you, Shruti?
Hi, Srini. I'm good. How are you?
Good, good, good. Okay. So how was your New Year?
It was good. It was very quiet. We didn't go to any parties, but we went to a New Year brunch the next day.
I see. Okay. Oh, that's
Yeah.
good. I was talking with Jishnu about this peaceful vacation, not doing a lot of events. Yeah, I guess that's kind of like things that people like, at least some of us like. So yeah.
Yeah.
Cool. Um, okay, so what should we do now? I didn't have anything prepared for the office hours. I was just like, okay, if there are questions, we can talk about it. I still have the lecture slides from the lecture I gave in on campus about the AI tools. Um, but I think maybe it'll be better if I start talking about it next week. Um, I might need to prepare a little bit as well. So today it's open, whatever you guys have. If there isn't anything, we can wrap up early. That's fine too. Anything you guys want to discuss?
Sir, sir, in the question you gave, right, like in the question that if I use for loop, it is not working. I don't know why.
Uh,
For
Krishna,
I in range some.
I cannot hear you properly. You're breaking up. Can you repeat
Okay.
that?
Uh, so in the question you gave, sir, that if I use for I loop and it's not working, like I don't know, man,
Give me some
for I
context.
in range.
Uh-huh.
So in the question you gave, right? So steering is equal to 0.3, something
Oh,
like that.
so which lesson is
Throttle.
it? Let's start from the basics. Just give me some context. Which lesson is this? Lesson one?
Lesson two, sir.
Lesson
Lesson
two.
one challenge.
Okay, hold on. Let me pull that up. Okay, so welcome to the simulator lesson, right? Tape one?
Yeah, yes.
Okay, so which part in that?
So in the question you gave, you asked us
Question.
to use the counter hint.
Okay, let me see the question. Oh, challenge. Okay.
Yes, sir.
Can you make the car drive forward in a circle for a while, then reverse? Okay. To track for how many times has been called. No, no, this property for now. Try adding a counter. Yeah, yeah. Okay. So now your question. What's your question?
In that question, if I use a for loop like for I in range 300 and then throttle, then if I greater than 300, change the steering, something
Mhm.
like that code, it's not working. I don't know.
Yes,
I
I guess I know what your issue could be. So the way you should think about this, it's kind of like the get control method is an re-entrant method. What I mean by that is, if you think about the whole system, it is a Jane for loop, right? So you have this whole thing running in a for loop, but you are not writing the for loop. The for loop is outside your control. So, I mean, if you look at the whole robotic thing and on the outside, it's like sense, think, and act, right? So you're just doing the thinking part. I run the for loop outside, which calls a sense, think, and act functions like continuously. So what really happens is at every time a get control method is called, whatever code you wrote comes into play. And so if you write a for loop inside that, then you're just doing a for loop inside that get control thing. Um, the right way to do that is you just add the counter in, and then once you and basically set the counter in the init method so that you don't get it reset every time, and then you just increase the counter value. And when you do that, every time the get control method gets called, the counter increases, and then you know that, okay, this is in what time step you are at. Does this make sense?
yes, sir. I understand.
Okay. So basically the main idea is like you are not running the main for loop. The for loop is happening outside in the simulator. And your method is getting called every time the for loop goes to the next time step. So it's called,
So,
these are
but
called,
even then it should work, right? Like even then it should work. Like
yeah. So, well, I
even
mean, the
the
thing is, yeah, even then, you can run a for loop within get control. I mean, I'm not denying that, but when you run that, you're not progressing through time, right? It's you're doing something inside that for loop,
yes,
right?
yeah,
So that's
yeah.
going to be a little like you can do whatever you want to do in the for loop, but whatever you want to happen is not going to happen, right? Like that's happening in the simulator. So you need to let the simulator do its stuff, or basically simulate the robot, proceed to the next time step. And then when you get to control, you can do what you want to do.
Okay, so the loop runs per frame in the way, like 60 frames you do.
It's approximately 60 frames depending on your compute available, but it is um, you don't have to put a loop inside the get control method. That's what I'm saying.
Yes, I
So all you
understand.
do is in the init method, create a variable, and then in the get control method, just increment the variable and then print it to the console, and just let it run. And you will see that like without even any for loop in the get control, the value gets incremented when the simulator is running. Once you do that, I think you'll get the idea of, okay, how this whole thing is getting called.
Sure, sir. I understand.
Okay. Yeah, I think it might have been
Yeah,
useful if I
yes.
put a for loop or like the diagram of how the whole thing gets called. Maybe I should add that in. Let me make a note of it. Okay.
If you just put a print statement inside the function and
Mhm.
run it, you'll just know how how often it's getting called in the console. So you
Yes,
can do that first before adding a counter.
that is true. Yeah, yeah.
Actually, sorry to interrupt, but am I the only one who doesn't have a context about this?
Sorry, I'm
Not
going to
sure
add
what.
it now so that you'll start getting it. So let me
Okay,
add
sure.
it. Okay. I added you, Jishnu. Let me send the lessons for you. Okay, so Jishnu, you should have received the first the welcome email on the in the first lesson, and you'll get the next lesson tonight.
Yeah, I actually got it.
Okay, cool. Yeah, I had to write like I mean, this might be an overkill, but I actually wrote the whole software for sending these daily lessons and everything. Uh, so it was fun. I like developing software, so this is a fun activity. Okay, what next? Like anything else we should, any other questions you guys have?
So when I changed the throttle in the auto mode, I didn't see any difference in the speed of the car.
Um, when you change the throttle,
Yeah.
okay. So in the bottom of the simulator, there should be a, let me, hold on, let me pull that up. Uh, Share my screen. Okay, do you see my screen?
Yeah.
Okay, so what you're saying is like when you in the code, if you change the throttle value, which is basically the value that you send return, you're not seeing any change in speed?
Yeah.
Okay, so the first thing is you could look at the speed here. This tells you like what is the current speed. And so for example, like I'm in the manual mode, I'm in the manual mode, and then I'm doing the driving the robot. You can see that the speed kind of changes, right? But then it would max out at this point, it's maxing out at 8 meters per second, right? Because that is the max speed that I've set. So if you go to the config, then you can see that there is this max velocity. And if you can change that to, let's say, 15 meters per second, then the car will be even more snappier. Um, and it go up to 15. So what you would have probably seen is you would have set some throttle. Since it's running at 60 hertz, it very quickly reaches the max velocity.
Okay. Yeah.
That's the reason. I mean,
Okay.
I could have added some momentum to the robot, like basically added some weight and set up the dynamics for it, which I tried at one point, but I thought it would complicate things even more. So I kind of like
Okay.
moved to just dynamics. I mean, moved to just kinematics and not the dynamics of the robot. But eventually, like in a real robot, what would happen is it will take some time for you to reach the speed, and it'll take some time to do to reduce the speed. Like there is this acceleration and deceleration, but in addition to that, there's also this momentum that you have with the vehicle. Even after you cut the throttle, sometimes even after you brake, you would still keep moving a little bit because of the momentum of the vehicle, which is kind of absent here because this one is
Okay.
just kinematics and it's not considering the weight of the robot at all. Okay.
Okay.
Yeah. So the other thing is like when I initially designed the simulator, I was thinking of like the more simpler way to do it is you would just say that what is the speed of the robot, and then you just set the speed, and then just make the robot stop or just drive. But then I wanted to have a little bit of realism, so that's why I added a little bit of kinematics to the vehicle and not just like, okay, what's the speed? So all you can control is not the speed, you can just control the throttle like a real vehicle. And you cannot, like in your car, you cannot control the speed of your car. You can only control the throttle, like how much you press the
Yeah.
accelerator
Right.
pedal,
Right.
right? So that's the reason why if I just stop it, even after I release the key, it would just keep driving a bit because of the kinematics of the vehicle. So, um, you will use that, I mean, you will kind of like see that issue, a little bit of issue later on. Um, but I didn't, I mean, I could have made this whole thing a big issue and have to kind of like deal with it, but I didn't at this point. But let's see how people kind of like react to this. And maybe in
Okay.
the next version, we can make it even more harder. Cool. Uh, any other questions? Did you guys um were you excuse me, were you guys able to start the simulator fine? No issues with libraries loading or something like that?
Yeah, it was working fine.
Okay, cool. Yeah, I had to make sure that I mean, it's kind of an odd combination. I wanted to have it in Python. I wanted it to program in Python, but then I also wanted it to be on a browser-based thing so that you don't have to install anything. So it's making it as user-friendly as, or like beginner-friendly as possible. So I had to kind of like, so that's kind of an odd combination. Like Python and web don't go together well. So I had to find the libraries that actually make it work. But I think I
Which
got it.
software is this?
Sorry?
What software is this?
I custom built it.
Oh, wow. Okay.
Yeah. So it's using Pydiode in the backend, which is kind of a web-based Python library. And then the rest of the stuff is just HTML and CSS and
Okay.
like regular set of things.
Yeah.
Yeah. Again, I mean, I like building stuff, so this is another fun project. Okay. Any other questions? I know it's too early in the challenge, so probably you might not have a lot of questions, but if you have anything, I can kind of address that. Yeah. So the editor itself is kind of like it's the Visual Studio Code editor. I mean, it's called I mean it's called Monaco engine. That's what Visual Studio Code uses, and that's what this is. So it's kind of like has all the features that you have in Visual Studio Code. I haven't tested it extensively, but for editing, I think it's kind of like works. You can do all the things that you do in Visual Studio Code. Um, and then you'll have these other, once you start turning on features, you'll have more fun with this. So this is one of the feature where like right, the default feature is you can pass through obstacles. Like if you hit the wall, you can just go through it, except that the color of the robot would change at the instance when you cross it. But you can set the settings so that it would not pass through walls. And when you do that, and when you do the autonomous mode, well, it's not moving. It would not go through walls anymore. So you have to program it for that. So I thought this default program would let you drive in circles. Maybe not. I don't know. Let me reload. Okay. Anyway, yeah, I had different versions of the code. And so I've also set it up so that it would be um, it stores locally. So when you just restart it, you'll still have the old code um, set up. So yeah, okay. This is the thing I wanted to show. Well, maybe it already shows that.
Yeah,
Uh,
I was about to ask that, like how session management and things work here. Like we don't actually have any login or independent thing where we
yeah.
can actually track different people.
Yes.
So
So so I made that part really simple, which is like everything's running on your browser. No server-side things.
okay,
I don't want to get into that hell because it's kind of like gets really hairy pretty quickly. So it is all like set up so that you basically download this whole thing from the server and then everything is running on your browser.
okay, that means
That's
it's
what
something browser heavy.
it is kind of browser heavy, but the kind of compute that you're running here, it's kind of like nothing.
Okay,
The browser nowadays are like much more heavier than like what you would see in this thing, right? This is pretty trivial, basic stuff. So, but again, that's also like the main goal for me was to um reduce the complexity as much as possible, right? At least for these kind of setups. The easier thing would have been to run Python on your computer and then start a Python server and then just run this locally. That's another way to do it. But I did not do that because I didn't want to assume that people will have a Python to start with, right? Like I just wanted to be browser based, like everything. You don't have to do anything at all. Just open the link and then you should be able to do it. So that's kind of my chief um, kind of requirement for this simulator was. So with that in mind, I just designed it. Um, it could have gotten a little browser like computation heavy on the browser, but I mean after I finished the whole thing and I realized that it was not that bad. So I just left it at that. Yeah.
that's
Well,
actually cool because previously I was searching for something that can be done with Python or not. When I
mm-hmm,
was actually trying to do something with the PID controller and
mm-hmm,
to actually code one.
mm-hmm,
So I was actually trying to get the simulation up and running, like
mm-hmm,
simple.
mm-hmm.
So, but I wasn't actually able to do that in the simulation part.
Yeah, I know. Like to me, like having running a Python program is kind of trivial because I've been doing that for years. But I do know that when you're getting started on that, um, like it could get like complicated, right? So that's the thing is like, okay, let's make it as simple as possible, minimum barrier to entry. And so that's what this is. So, I mean, the amount of hours I have sunk into this challenge is kind of surprising. I didn't realize that it would take me this much time, um, but I'm happy with the outcome. And it was fun. Like my wife was always complaining, like, okay, you're in your room always, never getting out. But I enjoy doing this, so it was good. So I hope people find it useful and can get. So my main goal was like, okay, when I talk about robotics, like people would be like, oh yeah, that's cool, but then they kind of like inherently think that, oh, maybe it's not for me because it's too complicated, it's too much math, it's too much mechanical, maybe I don't know how to program all those things. So, which is kind of like I mean, I don't, I mean, I'm passionate towards robotics, and I was like, okay, I started from nothing. I don't know, like, what it is. And now I have a PhD in robotics. So it's doable. It's just that you need to be shown the right way, right? So I wanted to have like an entry, to anyone who just wanted to do robotics and try it out. So this is a challenge for that. It so that being said, this might be too basic for some people who have already been into robotics. Um, but nevertheless, they will pick up some of the skills, because what happens is when you're learning things, you learn some complex pieces, but then ho- when you try to put things together, you wouldn't know how to do them because you were not shown how to do that, right? So you just learn the pieces, but then you don't know how they all come together. So this one, in this challenge, I made sure that it all comes together in a proper way, so that you can have like this whole system set up, that can do this whole thing. So as you go through the challenge, you'll see like, okay, different things get added, and then I also show you how this all comes together into one cohesive kind of system. So, okay, I've been talking too much about the simulator, but it basically shows how passionate I am about this. But yeah, I guess gets boring after a certain point. Anything else?
No, I was actually going through
Oh,
the Pyodide doc.
Oh, nice. Okay.
Sorry.
Sure, that's okay.
That actually, I think they got a CDN for serving that package, right?
I think so. Yeah, yeah.
Yeah. Okay.
So the other kind of like thing is like I've used a lot of AI in this to develop this. So that's another thing that I'm kind of experimenting with. It would have taken me 10x the amount of time, probably more, if I just wrote everything from scratch. So that's another thing I'm kind of like realizing that with AI, everything gets accelerated. I mean, you still need to be in the loop. It's not like, okay, press a button and everything comes up. That's never the, I guess that'll never be the case. It's you still have to, you will still have um, your part where you would have to convey your intention, like what you really want to do. And that's kind of the main important thing. Um, Eventually, it'll get to a point where, like now, just a handful of people in the world would actually worry about assembly language programming, right? In the past, like maybe 20 years ago, a lot of people were doing it, but compilers have gotten so good that you don't have to worry about assembly language anymore. It does the translation for you really well. Like if you're learning assembly language today and trying to program something, it's 100% certain that a compiler will do a better job than you hand coding it. So that's how good compilers have become, right? So just a handful of people in the world actually worry about it. Probably those people are the people who kind of design and update compilers. So that's how it turned, right? So I think similar thing would happen with programming in general, like all the C++ and Python and everything. Um, AI would take care of most of it. You just have to give your intention on how it is. You would probably not even look at the code. And when that happens, maybe a few years after that, these languages will also go away, because why would you convert to Python and then to assembly? Just can write in the language the computer understands, right? That's kind of like getting rid of this additional layer of redirection or complexity. So that's where I see this is going. But in the interim, we can have the fun of playing with these languages and looking at the code and all those things.
But that would make the AI like a superhuman species, right? It's like better than us. Like,
No, well, I mean, okay, so okay, it is not. I would disagree to that. So even today, computers are better than us in a lot of ways. For example, let's say autonomous driving, right? Um, you can have a car driving autonomously for 28, 24, 48 hours in a row, like continuously, whereas you cannot. like maybe that's not a good comparison. Let's say that your car can see 360-degree around the car, whereas you can just see like maybe 60 degrees in front of you. That's all it is. So the car does have more capability. It's kind of superhuman in that sense. It's more like you have four drivers like looking at all four directions and then driving, right? You can never do that. So similarly, like let's say you are crunching some math. We can crunch math at only a certain speed, whereas computers do it at a very lightning fast speed. So computers are already good at, or even better, or like unmatched in certain areas. Where we excel is setting the intention. Like when we talk about like, okay, what are the things we could do? Like when you want to look at the whole big picture and kind of making decisions, basically consciousness, right? That's where we excel. And computers do not, or at least not yet, have that taken that spot. Um, but yeah, I mean, eventually it'll get better and better. Um, I still don't see the use case or see where it would replace us completely, but I can see that the places that computer would take over would keep increasing. So I think what is really happening is like the more and more computers kind of get intelligent, we are moving into the more and more meta levels. So before like industrial revolution, we were building all these things manually, right? And then when industrial revolution happened, people thought that okay, yeah, a lot of people will get the jobs, and people were in industries doing stuff, factories doing stuff. And then when our automation came in, people thought, oh, maybe all these people will lose their jobs, and all these jobs would go away because now automation is kind of taking over. It happened to some extent, but what really happened was people moved on. People moved on to a higher level, and then the automation took over the most of the menial jobs. And I think we are seeing this more and more happen, right? Like as computers and uh, AI and everything taking up easier things, people move on to a higher level, and we do the meta stuff. So even in this one, like if you um, instead of just writing the code line by line, I was just guiding the computer to do the stuff. And but I still needed to be there to say that okay, this is what I really wanted, and to make the computer do what it had to do. So I think people would lose jobs. Actually, the job descriptions would change quite a bit. But I guess people will still be in the loop. And I was reading somewhere that it's not going to be like, I mean, one of the fear that people have is like, okay, computers will take up all these jobs, and a lot of people will be without job. That is also not going to be the case, because what really happens is once you figure out how to automate or do things with computers, then you kind of start to imagine possibilities that are way beyond what we imagined before, right? So before the this computer revolution happened, or like all these computing things happened in like 20 years ago, a lot of computing was just like okay, spreadsheets, like this Google. Sorry, Google was not even in the picture then. Like Microsoft spreadsheet program, Excel, and all those things in the text-based or like menial graphical-based stuff that was coming out, and people thought that's what computers would be used for. But we ended up using computers for a whole lot of things after compute became more accessible, right? So similar things will happen going forward. Like applications that we have never even thought about would become a reality, and then we'll need even more people to kind of like command the computers to do the stuff. So the requirement for people would actually increase. What is going to be a problem is people will not be equipped to do stuff. So if you know how AI operates, how this whole thing like um, I mean, so for example, if you know how to invoke an API to talk to a AI LLM, then you can do certain things. But if you know how an LLM operates internally, then maybe you can kind of fine tune, or you can think about use cases that are not possible when you just knew the how to use the API, right? So the more you know, the better application you can come up with. So that's where the next bottleneck is going to be. Like a lot of people would know how to do programming in Python or C or whatever it is, but they probably don't know what an LLM is or how it operates or how to even invoke an API to use it. And then when that comes into play, then you'll have a lot of job requirements, like a lot of openings, but not a lot of people to actually fill them in, which has always been the case. Like people, it's there is always a lag in people upskilling themselves uh, to the requirement, right? So that will continue happening going forward. So the sooner we all upskill ourselves, the higher the chain that we can move up. Sorry, I don't know if it was a rant or if it is useful, but this is what my thought process is at this point.
But I think that, let's say ChatGPT, when we are using, everyone is typing their context. So everyone is telling it the context, like I want this, I want that.
Mm-hmm.
So because of that, they will also have the data of context. So
Mm-hmm.
like how people are, like what are the needs and how they are thinking. So
Mm-hmm.
now we have the data of context data also. They have it, so they
Mm-hmm.
can make. So like so they can even make the context, I believe, and that's what I'm thinking. And the other problem, I think, like it's like we can create a lot of AI agents, right? That it it improves. It's like so it's like if we can create a little specific point where it will show no bugs,
Mm-hmm.
then then it will, like, it can break the internet, right? Like it can do anything.
Yeah, well, I guess the thing with no bugs, that never happens, right? So that's the nature of things. So, I mean, I don't know. There is a book I read about how we simplify things. So, like when studies come out that okay, there is a huge rise in obesity and there is this kind of like increase in the obesity, what people do is like okay, they just interpolate that, make it as a linear graph and say that okay, in 1950 everyone would be obese. That's not how things happen, and that's not how things are in nature. What happens is you have a sharp rise, but then it kind of tapers off at some point, right? There's a You can never have like an exponential curve like always going up, not with behaviors and how people operate. So there's always going to be a lot of people who are going to be obese, but then there's going to be a huge population that's kind of like not obese. And there is also this thing about um, consciousness where people do act, and so that graph gets broken. But anyway, what I was going for was like you'll never get to a point where it's 100% correct. There'll always be bugs. That So it's impossible, and people have been trying to go like with 100% like no bugs for any system, and it never happens. That's not how nature operates. So there'll always be bugs, and this, as I said, the systems would become really powerful, and you can even say superhuman, but humans will be in the loop to kind of like specify what needs to happen. The intention part of it is still human at this point. We haven't figured out how the AI should have its own kind of intention. So, yeah.
Actually, I would like to add to that because what I see is it's like uh, in the late 1990s we had this dot-com bubble or the internet bubble where internet was actually getting introduced and it was actually growing in a fast pace. What
Mhm.
I see here is like AI is also like something like that. Uh,
Mhm.
Currently, it's going to the peak and it will reach a point where it cannot grow much, and even that bubble is going to burst at some point in future.
I don't know about that. So I think people have been talking about a bubble bursting in the past at least 1.5 years to 2 years. It's not happened yet. I guess, well, the first thing is like if that happens, it'll be really, really, really bad for the industry because they've pumped in billions of dollars into it. And if it goes bust, Like remember in 2008 when the market went down, it was like not growing. It was kind of like stagnant for the next 6 to 8 years. Nothing happened for the next 6 to 8 years. So I think in this time, if that happens, it'll be really bad, and there's going to be a lot, maybe even longer time when there'll be no growth. So personally, I wouldn't like that happening. So the next part is it's not new for AI to go bust. Like AI, the term itself was coined in I think in the 1950s, and there's been like several cycles of it, like of it being promising and going bust. Like when they initially started, I think Marvin Minsky and other people actually started that, and it kind of like they said, okay, in AI is going to do a whole bunch of things. That's when all these imaginations of, okay, AI would be, you have a robot butler in your home preparing food for you, and then you have flying cars and everything. But that never happened, so it went bust. In 70s, I think they started these um, other things, and there was this expert systems that were getting a lot of attention, like fuzzy logic and expert systems was kind of like the big deal. It did deliver to some extent. Even like 2 years ago, I was using an expert system for spectral analysis. It's pretty good, but well, it's not lived up to the hype. And then that went bust. And then came the neural network thing, right? So that's when neural networks, I think in the 90s is when the neural networks was introduced. And it was a big deal. Even at CMU, they built it's called Nav Lab. It's like a big truck with camera processing this information and take building a neural network and figuring out which is a road and then driving it. So this is like 20, 30 years before we had self-driving cars. So they made these kind of things. But again, that didn't live up because you didn't have enough compute to do those things. And then in 2011, or when it's when we actually had this old neural networks, which had these GPUs in the back end and do these things. And ever since we have been growing. So if you look at it, that is the bubble we are currently in. Like in 2010, 11 timeframe is when this happened, and it's been growing, growing, growing. As long as there is some meat to it, in the sense that as long as we can, the applications are there and the finances are there, the bubble would not burst. And if it kind of sustains, then it won't be a bubble anymore. It'll be just sustained, right? The bubble really happens when people overestimate and then they find out that okay, the applications are not supporting and the economy is not there, then things would be bad. uh, Luckily, I think it hasn't happened yet. As I said, I don't want it to happen. It will be terrible, but I see that there are some hope because uh, like in the past 2 years, I think it's 2.5 years since ChatGPT came into the picture, right? And I think even 2025 was mostly like people, a lot of companies started shifting from top end models to actual applications, right? All these cloud code and cursor and everything were like, okay, great, you have a great model, but what 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 what's the problem with that? Like, I mean, there is nothing like if you are not having an application, then there is no point in having such a great model. So I think the focus has switched to applications, and this year it's going to be even bigger because I mean you can already see um, the thing with that, like ChatGPT, when they came up with the most latest model, they didn't even announce it as a big thing. They're just like, okay, yeah, we have a new model. That's it. Because no one really cares about new models anymore. It's like, okay, what can you deliver? That's where the industry is going. So I think that is a good thing because if they can deliver on that, which I think they've already been delivering, and if they continue doing that, then this bubble is not going to burst. But if not, then yeah, it'll be bad for all of us.
Actually, what I'm concerned is like the amount of actual good data.
Good data. Yeah.
Actual like yeah, that's what concerns me more.
Yeah, I think
Uh,
they already
the,
hit that wall. So all the companies, I mean, on in the back end, they are not processing all the data, right? They're just getting the data from some other company subcontractor who does this thing. And these subcontractors are kind of limited there is limited data on the internet, and they have sanitized all the data, and all the companies have all the data. So there's no longer a data differentiator. Data is not a differentiator anymore. So that's why you can see that the models are not saying that, oh, we're becoming bigger. It's more like, okay, what are the model changes we can make that can make the model better with the given amount of data? I think even recently, like a day ago, DeepSeek came up with a new update to their architecture that would actually make the transformer architecture better. So yeah, I think people are moving on, like realizing that, okay, you're not going to get any more good data. So let's just make the model more efficient so that it can process it in a better way. So yeah, I think your fear is correct there, but people are addressing that already.
What do you
Yeah,
think
let's
about the power
wait.
center?
Sorry?
So what do you think
Yeah,
about the power? Like the whole data is with US, right? So like the whole like
The
GPU,
privacy
everything
thing?
is in, yeah. And privacy, not just privacy, they have access and like they can chat with anyone, like personal chat, like ChatGPT can personally chat with me, right?
Yeah.
So I can get influenced by ChatGPT, so it can make propagandas and anything like that. I think that's also a very dangerous part, I believe, right now.
Yeah, which is, I mean, yeah, it is true. Um, I don't know. I haven't delved too much into it. I know it is a problem, but I don't know what the solution there is. I mean, I guess no one really knows that, right? Because we know that, okay, a lot of data, really important data, is getting aggregated by these big players, and we don't know how else would you do this thing. Like, you don't want to stop the progress, but at the same time you don't want to hand them off all the data. So my guess is probably a big event would happen, big bad event would happen, and then the governments would be like, oh, this is bad, let's regulate this, and then they would start regulating it. At this point, there is no big motivation to regulate it. There is like one incident with ChatGPT, kind of like encouraging uh, like kids to, I think there was a bad event where there was a lot of suicides and things like that. So so with that, I think there was a little bit of scrutiny there, and ChatGPT made some changes there. So something like that would happen. Unfortunately, it's kind of a reactive industry, right? You cannot, like, the governments cannot go in and proactively do that because the companies would not allow that. So for this to be regulated, I don't know if if regulation is a good thing or not, but maybe that's the solution that we have known so far. So maybe something like that come into play, and then maybe they'll get a little bit of thing. But no matter what, the privacy that we knew before is gone. Like in the social age, I think it's already gone, right? With social media and everything. So it is kind of like, it's again, it's not a on or off the kind of thing. It's more like a spectrum. So before internet came in, people had a lot of privacy. After the internet, the privacy has started going from like nothing at all to like, okay, everything is kind of like exposed. So we are not there on the very end, at the other end of the spectrum. But slowly going towards that. So if you really worry about it, you should probably not talk to ChatGPT. But even if I say that, you'll do it. But one kind of like a intermediate solution is, if you really worry about it, you can actually run the models locally. So the models would not have as much power as running it on like on the cloud, but you can locally run your models, and then you can talk to it. Um, so I have done that in the past. Like, there are tools like Olama and LM Studio, where you can get these models. When I say the models are not powerful, what really happens is these models are quantized. So what I mean by quantization is, let's say your model has like 20 or like 2 billion parameters, and each parameter is a float. And then when you talk about 2 billion floating point numbers, that will be several gigabytes of data, right? So you cannot physically fit in several gigabytes of data on your RAM. On a cloud, yes, sure, possible because you have these great GPUs and RAM and things like that, so you can load in that. But on a computer, you cannot. So what they have done is they said, okay, let's take this 2 billion parameter model, but instead of using 4 bytes to represent or 8 bytes to represent a floating point number, we'll just use 1 byte or 2 byte to represent that. So what that means is you're basically rounding off that floating point value, right? So you have a similar model which has similar capabilities. Now you can load that on your computer, but it will not have all the great intelligence as the cutting edge model because you've already rounded it off, right? Um, but for trivial things, it does surprisingly well. I've tried that in the past. And this is what I was advocating for people who wanted to run things locally, like giving code generation and things like that locally, where you cannot send your software out to a different vendor. Like if you're using Cloud Code on your repository that you don't want to be exposed, then you're kind of exposing the data and the code, right? So those things, if you are using just the local model, then you can be certain that it's not going out. I know it's a tangent on a different direction, but I guess that's useful information if you guys are interested in that.
But I think it's like suppose there is a person that's similar to me and thinks like similar to me, and then even if my data is not exposed, my data is exposed. We can say that like
That's not true. Like no two person would think in the same way, right?
yes, sir, but on the large scale, we might think the same, right? Like for example,
No,
both
no,
of us might be.
nope, that's not possible. So it's basically like if you look at the possibilities, like even if we clone you, just make the exact copy of you at this instance, the experiences that you get and the clone gets is going to be different going forward. And that would change. It's kind of an exponential thing. So yeah, I mean, I cannot give you the intuition of this, but it's more basically like this is how cryptography works. If you have this, you have this huge number of possibilities, and you just randomly choose one, and then if it's really random, then the chances of hitting the same set of numbers is going to be like kind of impossible. And the impossibility is like not in the order of like hundreds of thousands. It's like on a very high scale. So yeah, I
So,
don't know if
but
I
like,
can.
but for example, if there is an event, like there is a like some event, bad event happening, and
Mhm.
then we can say that most of the people will be aligned to yes or no, something like that. Like what
I
I'm
see.
trying to say is like, uh, so we can make the things where people might think similarly. Like we can wait for such moments.
Well, making people think similarly, that is different from like having identical kind of thoughts. Yeah, I think the thinking similarly is what like most of these uh, like when you have a kind of someone influencing and doing certain things. But yeah, so that's possible, and that will happen with these big models coming in, and maybe if someone tries to influence them. But yeah, it's possible. I mean, that's what I said about like no one really knows where things are going, and so we are at the cutting edge, right? So um, we'll have to wait and watch. I think we are at the top of the
Yes.
yeah. So we'll stop here and we'll pick up next week. So I think since I've talked a lot about AI, I think I'll bring up the AI slides next week and we can continue the discussion on that. And maybe that'll help us progress the arguments even further.
I think actually Shruti was about to talk about something and the conversation just went
Oh,
in
sorry, I
another
know
path.
that.
I don't even remember now.
Oh, sorry, Shruti, I didn't notice that.
No, 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 no worries. No, actually, I don't think. Yeah, I'm not sure what I was going to talk about.
Okay, cool. That's okay.
Yeah, it was an interesting conversation. No worries there.
Okay, cool. I'm happy you guys enjoyed it. Okay, cool. So I'll meet you guys next week. Shruti, I think we are meeting after this, right? So
Yeah.
you can stay on the call. Okay. See you guys.
Bye.
Bye bye.
Bye.
Thank you.
Mhm.